Absorption of heat calculations. Previously, we looked at Q and delta H being the same. Why? Well, delta H is the product, is the sum of the delta U, the change of internal energy of a system, plus the product of the constant pressure times the change of volume. This needs to go out. If it comes out of a system, where's it going to go? It has to go into the surroundings. So it's going to be absorbed by the surroundings. Why? First law of thermodynamics states that the change of energy of a system, which will be this one here, must add with the change of energy of the surroundings, which is over here, which is equal to the change of energy of the universe in total. So if our delta H gives off energy and it's created in here, well, if it releases energy, it needs to be a negative value because now it becomes exothermic. And the Q is going to be the opposite, so the opposite of negative is positive. So it's going to take in and absorb that energy transfer. So this one becomes endothermic. Now it's not as simple as saying that the delta H is equal to Q, because the Q, the surroundings, when it takes in that energy transfer, it is also dependent on the Q's mass, how big or small it is, the amount of matter that is contained in it, the specific heat capacity, so the amount of heat required to increase 1 gram by 1 degree Celsius. So if it's a higher heat capacity, it's going to be more difficult to increase it by that specific temperature because more amount of heat is required. So the amount of perturbation to be moved is more difficult. Then delta T stands for the change in temperature. The temperature of the final minus the temperature of the initial. So like I said, the heat absorbed is dependent on these variables. Let's look at an example of a question. 1 liter of water at this temperature, initially, is warmed by the addition of this much heat. What is the final temperature? Well, you just have to plug in your values appropriately. Make sure that your kilogram here is changed into the grams, because as shown in this table here, our specific heat capacity has our joules in the numerator, and then our grams multiplied by the Celsius temperature on the bottom in the denominator. Another thing to remember is that our kilojoules here need to be converted into the joules, as shown here, and our TF is what we need to find, which means we have to isolate it on its own, and our temperature initial is going to be our 1 degree Celsius, because in the question it states that it was 1 degree Celsius initially. Once you isolate for TF, you're going to get 1.95 degrees Celsius. I want you to try a few questions on your own. Pause the video, and then I'll give you the answers. These are the questions. This is the answer for the first question. This is the answer for the second question.